Hi, this is Alexandra Davis, and this is my project on nuclear fusion. So what is nuclear fusion? Nuclear fusion is the process of two smaller nuclei fusing to form one larger nucleus. When nuclei combine, an enormous amount of energy is released. The energy released is even larger than in nuclear fission. So where does nuclear fusion occur? Nuclear fusion occurs naturally on our sun. The sun provides the ideal conditions for nuclear fusion to occur. Without the heat generated from nuclear fusion by the sun, life would not be possible here on Earth. Interestingly, although the sun produces power from fusion reactions, it does so very inefficiently. Here on Earth, scientists are aiming to produce energy as much as 1,000,000 times more efficient than the sun. So what does fusion require? Fusion requires two isotopes of hydrogen, deuterium and tritium. Deuterium has one proton and one neutron. Tritium has one proton and two neutrons. When fused, these isotopes create a helium nucleus. Large magnets are also needed to keep the atoms close enough for the reaction to occur. The other thing needed for the reaction to occur is for deuterium and tritium to be in a plasma state. So what is plasma? Plasma is considered by some to be the fourth state of matter. This occurs when enough heat is applied to free the electrons from their attractive forces and creates an ionized gas. For deuterium and tritium to reach this state, they need to reach temperatures upwards of 50 million degrees Celsius. The most common magnets are the tokamak and the stellarator. Tokamaks gained popularity after 1968, when the Soviets made a breakthrough with the tokamak, reaching temperatures 10 times what was previously achieved with the stellarator. After this, the tokamak became the primary magnet used for fusion research. A tokamak is a large donut-shaped magnet that surrounds the center of the reaction. Stellarators are also donut-shaped, and they use strong magnetic fields to contain the plasma. Stellarators require less power to sustain the plasma, and it allows for some simplification of plasma control. Unfortunately, stellarators are very difficult to build and didn't start coming back into favor until recently, when computer modeling techniques allowed them to have the correct geometries to operate efficiently. So what are some of the greatest challenges to nuclear fusion? The biggest issue is that we put more energy into starting the reaction than what the reaction produces. But scientists have theorized that if they can create ignition, harnessing the power of nuclear fusion could become a reality. Even if fusion reactions are achieved and sustainable, the nuclear fusion reactors need to be much larger and therefore much more expensive than fission reactors. So what is ignition? Ignition is the idea that enough fusion reactions could take place where it becomes self-sustaining. Once ignition is achieved, several particles, including alpha particles, are released. These continue to raise the temperature of the surrounding plasma. The even hotter plasma then releases even more particles, and the cycle continues. Ignition was achieved recently for the first time, on August 8, 2021, by the National Ignition Facility. This reaction produced 6 times more energy than any fusion experiment previously achieved. But still more energy was put into starting the reaction than received from the experiment. MIT recently produced a stronger electromagnetic field than ever before on Earth. This was achieved by using high-temperature superconductors. Tokamaks around the world currently use low-heat superconductors. This experiment was achieved by using a new superconducting material just developed a few years ago, which allows for stronger magnetic fields in a smaller device. This new material showed that a magnetic field using this material can be 40 times smaller than the current devices and just as effective. The ITER is currently under construction in France and will be the world's largest tokamak. In about 10 years, the Chinese engineering test reactor is set to be finished and is expected to be even bigger than the ITER. Many countries participate in fusion research, including the countries in the European Union, Russia, the United States, Japan, China, Brazil, Canada, Korea, and many others. The more established countries have been helping other countries financially and through sharing of their facilities. This is done to help bridge the gap of knowledge and develop fusion research worldwide. So why is nuclear fusion needed? In an age where the Earth is rapidly heating through the use of fossil fuels, alternative energy sources are needed now more than ever. The main byproduct of fusion is helium, so it doesn't contribute to greenhouse gas effects. Nuclear fusion poses no risk to public safety, as a nuclear fusion reactor meltdown is impossible. Nuclear fusion also produces less radioactive waste than nuclear fission. The fuel used for nuclear fusion are isotopes of hydrogen, and these can be easily distilled from water, which means its energy source is very abundant. In conclusion, nuclear fusion holds great potential, but there is still much more research needed to be done in the field before it's a viable source of energy. Thank you for listening to my presentation on nuclear fusion.